Okay, let's go through question one. If you got the right answer to this, well done. This is not an easy question to start off with, but let's read through the question and extract the information. So it says a siren mounted on a police car emits a sound of wavelength 50 centimeters. So that means our lambda naught, the emitted wavelength, is 0.5 meters. As the car approaches a stationary observer, the sound detected has a wavelength lambda 1. As the car then moves away, it has a detected wavelength lambda 2. The difference between the wavelengths is equal to 0.068 meters, but the difference is just lambda 2 minus lambda 1. Given that sound travels in air, that's given us the velocity of the wave of being 340 meters per second. Calculate the constant speed of the car and the values of lambda 1 and lambda 2. So we're being asked to find the speed. Now we've actually got two different situations here. One where the car is approaching the observer, but in which case we'll have to take the velocity of the source to be negative. So if we just take the speed to be a value without a positive or negative, when it's coming towards the person it's going to be negative, and when it's moving away for lambda 2 it's going to be positive. Okay, where S there is the speed of the car. Remember, speed doesn't have a direction, so it won't have a positive or negative by itself, but the velocities will. Okay, and then we just start off with our equation for wavelength, which is lambda is equal to 1 plus the velocity of the source divided by the velocity of the wave times the kind of emitted wavelength. Now we're going to do this twice, so let's do it for the first case where it's moving towards the observer. Put in our values, so lambda 1 is equal to 1, and this time it's moving towards the person, so we're going to take it to be a negative s divided by the speed of the wave, which is 340, multiplied by our emitted wavelength, which is the wavelength of the source, which is 0.5. Multiplying through by the 0.5 gives us that lambda 1 is equal to 0.5 minus s over 680. We do the same thing for lambda 2, and we're going to get the same outcome, only the speed for lambda 2 is, or the velocity is positive. We can then use this information up here to link those two things together. So we have that lambda 2 minus lambda 1 is equal to 0.068 meters. Well, lambda 2 is 0.5 plus s over 680 minus lambda 1 is 0.5 minus s over 680, which is 0.068. Working out the left hand side of that equation, those two will cancel out, and the minus and the minus of the s in the second bracket will actually turn into positive, so we get s over 340, or 2s over 680 is equal to 0.68, and then if we multiply that out, it gives us that the speed of the car is 23.12 meters per second.